my name is James Sylvester from JPS Reliability. You may have seen a few of my posts on LinkedIn through my web blog, theseasonanalyst.guru. I've also just published a book, Enhancing System Reliability Through Vibration Technology, which is like a practical source-like book. And also from this May, I'm pleased to announce that I am an RMS trainer with the Reliability Training Institute. So to support the book sort of being published and also my new additional role with RMS Reliability as a trainer, I'm going to be sharing 5 case studies, one a week. So this week is number 1. As an introduction to these case studies, I'm going to show a selection of issues from various clients and problems I found, how we work to determine the actual failure cause, the mechanism and the mode of detection of the common failures so we can prevent them from happening again. One thing I see which does affect reliability a lot is that you have reliability engineers in design and manufacturing where they look at the physics of the system and how things all work together. They design a system with a certain reliability, it's put into production, and if we do not know how to run that machine correctly to keep the reliability up or how to maintain it, then how it affects it all goes downhill. So for a plant to be truly profitable, they need to link the two together quite well. And that's what I've been doing with Dr. K at the Academy. But this is where we're trying to integrate the reality of what we see in a workshop floor to the theory, the science behind reliability, and get them to work together. Very briefly about myself, I started as a machinist fitter or millwright. Did that for 10 years in various mechanical sites, chemical plants, and what have you. And then in the year 2000, I had the opportunity to move into condition monitoring. So it's been 20 years now. I have a look back since, had some great opportunities, worked in Australia for a little bit as well. But yeah, I'm just like at the point, like to share knowledge and increase what people know about reliability and condition monitoring. So these case studies, this very show we try and make the theory into the practical. Got 5 case studies to go through. Today's is electrical motor terminal connection defect. So we got called to this site. We had some old historical data on this, and it was about 1 millimeter per second RMS. Jumped up to 3.9, which I suppose ISO isn't bad, but there's a huge change in condition. Went back 2 days later, and it's up to 8.8 millimeters per second RMS velocity. In between those 2 days, someone else has come in and done analysis, and they said the driving bearing was hot. I asked the bearing, change the bearings. So we wanted to get some more data, behind our decision. So this is the velocity spectrum where we can see, which wasn't there before, is a 100 hertz peak. Then what we did, we took some peak view data and lots of electrical noise, which peak view does tend to pick up. But this was the change in the pattern. You see we have lots of 100 hertz series and also 25 hertz harmonics. So this was a change. To look at the data differently, we put in a circular plot. So we ensured the RPM was spot on, 100%. Circular plot, and you could see that there's 4 pulses per rotation of the shaft. Coincidentally, it's a 4-pole motor. This is the acceleration data, where we have 2 mounds of activity here, and this is sidebanded by 100 hertz. And at this point where we need to use your common sense as such. So while I was there taking the vibrational readings, touching, smelling, feeling, and yes, the side of the motor was hot. But this is electrical anomaly. This is a really large motor up on a pedestal. So I managed, as I clamped the motor, to touch around and feel, and the actual power cable going to the motor was hot to the touch. So I said to them, well, I've got an electrical defect. It's picking up a vibration. You can touch it and feed it. And as if the motor was bumping, missing the heartbeat as such. So it's not mechanical, your bearings are okay, something electrical is causing the problem, some connection, and the recommendation was to check all the terminations. So they took the terminal box off and they found one of the phases had got a little hot. I asked them how long his motor had been in, only been in 3 months. So straight away you think, well, why did that connection get bad in 3 months? Now, it was great that vibration picked up this, but you had to use your human senses and a bit of common sense to work out what component was actually causing the issue. But here's an image I got off my good friend Austin Dunn from the IRT training. So if I had a thermal camera on this particular job, then if you scan the motor, this is what I would have seen for sure. This shows you here our terminal box at 105 degrees, 30 degrees ambient. And one important thing to note is here, as the temperature comes down here, it reduces. So you know it's not overloading. There's a problem here. And this image here, you can actually probably say it's a connection up there. So this is sort of to say, don't just use vibration, don't just use thermography, don't just use ultrasound. You've got to use them all together. And that's how, if I did have a thermal camera, you'd have picked it up bang straight away. But through vibration, I did find out what was causing it. So when we stood back and we tried to work out what was actually happened to it, we said, well, what was the failure cause? Well, 3-month-old motor, an experienced electrician, unfortunately, couldn't have done the connection up to the correct torque. So you can say the failure cause was human error during installation. Now, the failure mechanism, that was high resistive connection. So as those plates were loose and some molecules and starting to move, getting the little friction and that high resistive connection increased the temperature, and the mode it was detected through increase, noise, and vibration. Now, so the summary is an incorrect electrical connection, human error, in the motor cable terminal box initiate heat generation that in turn caused vibration and noise and the motor to run really bad. Now, this was detected and occurrence of a negative functionability event was prevented. That means it didn't stop mid-production and cause a big backlog. It wasn't negative, a negative event. So with this knowledge of condition monitoring here, we've highlighted why the issue occurred, so we can look at ensuring that people follow procedures. And also on the side of this motor, probably a double check on connections. But it managed this company to put a quick plan in place to mitigate causing a stop in production, to manage that shutdown, to change the motor out, because they knew they had to change the turbine box and just change the motor. So, as I said before, I'm James Sylvester, JPS. So we can help you with upskilling your team in mentoring and the practical side of how you actually do it on site, contract reliability services. And as I say, now I'm very proud to say we're a Mobius Institute accredited trainer working with RMS Training Institute, and we're delivering the training for self-paced online as we're doing a lot of now, and I'm citing classroom when we can get back to that in vibration analysis. This is a slide I like to put in which shows you the technologies and how they're all interlinked. These are the 4 main technologies. Obviously we've got electrical, signal analysis, and current analysis, but these are the main 4 which people use, and you can see the type of defects and how they're all interlinked to each other. A little bit about myself. Well, me and the other chap, 40 years experience combined. We're from the practical side, worked our way up with all the theory and all the training, got registrations, and obviously all 4 of the book. Now, please, I encourage you to go onto the website and check out this science. It is very, very high-level science, but he's got it bang on, and it does fit in perfectly with reliability and maintenance and the practical side. So thank you very much for watching this first one. I say we've got 4 more to come, and hopefully you're finding them informative.